Okay, the law of sines is next. Law of sines, again, is one of those laws that we'll use when we're trying to find missing pieces of triangles that are not right. So oblique triangles are triangles that are not right triangles. Obtuse or acute triangles is what I'm talking about there. We can't use, as I mentioned in the other video, we can't use these traditional trig functions in this setting, right? Because those only apply to right triangle trig. So in the law of sines, it looks really, really different than the law of cosines. We have three fractions equal to each other. Right here we have the side, lowercase a, capital A is the angle A. Remember, they correspond because they are across from each other. Lowercase b over capital B, lowercase c over capital C. All right. So, having said that, the reciprocal property also comes into play, and we can also use the flipped over version. The flipped over version meaning take all those fractions and just flip them over. All right, and it depends on really what you're trying to find in a particular problem. If you're trying to find a capital letter, use this version, because you should always put the missing variable in the top. Use the version that has the missing variable in the top. So if you're looking for angles, use this. Use this when you're looking to find angles, and use this when you're looking to find sides. Just makes it a little bit easier in terms of the arithmetic and the cross multiplication and stuff like that. All right, when do we use the law of sines? Well, you're going to use the law of sines when you have these two scenarios. When you have a scenario where you have two sides and an angle that's not in between them, so that angle is not included in between here, or when you have two angles and any side anywhere. All right, when you have that situation, I first want you to calculate this missing angle using triangle sum. Okay, so again, if you needed to pause that, take any of those notes, please do so. We're moving on to example 1. We'll do 4 examples just like in the previous video. First one, find the measure of angle B, which is of course down here, so we need to find that measure. If we're looking for the measure of angle B, I want to use the version that has capital B in the numerator. So we're going to use this version. Now the interesting part about the law of sines is that you don't need to use all three at the same time. You're basically just using two at a time. So it's our job right now to examine what we're given and figure out which one of these fractions we can eliminate. Well, we clearly want the one that has B in it because that's what we're looking for. So we're going to keep that one. Capital C and small c are given, so we're probably going to keep the middle one. And you'll notice that A is not given right in here, nor is lowercase a. So that's probably going to be the one that we're going to eliminate. We don't need that one. We're just going to use these two. Okay, so we're looking for capital B, so we're going to leave that blank. Lowercase b is 21. Capital C is 119. And lowercase c is 32. Remember, capital letter, lowercase letter across from it. That's how that works. It's nice correspondence there. All right, so back when you learned proportions, back when you were probably 6th or 7th grade, your teacher probably said, all right, well, let's just cross multiply every time, cross multiply. All right, that's fine, but here it's kind of like a little bit silly. Leave the sign of B where it is, take the 21 and move it up to the top. Take that 21 and just multiply it by the sign of 119. So that I'll leave you with this. Sine of capital B is 21 sine 119 over 32. Notice the 32 doesn't go back up here because you would just have to end up dividing by it anyway. Alright, so let's go to our calculators and see if we can get ourselves an answer here. Let's go and type in 21 sine of 119, close the parenthesis, divided by 32. It's very important that you close that parenthesis. If you don't, I'll show you what happens if you don't. If you don't close that parenthesis, you're going to get an answer that's different. If you just leave it like that, your answer is drastically different. Alright, so we want to use the 0.57396. So the sine of capital B, 0.57396, and that goes on, right? We're going to let our calculator do the work here. So we're looking for an angle, so we're going to hit the inverse sine. So inverse sine second negative, which will give you the answer. So inverse sine of that answer. And there's a problem. What is the problem? Oh, I know. Because it's taking this answer. So we need to get back on track here. So I'm going to press second enter until I get my, this has like a little memory in it, right? So this is the one I wanted. All right, I'm pulling up all the previous typed in entries. Press enter, second sine, second answer, and that answer function is a copy paste. It brings that answer down to your next line, and you get your answer 35.027 degrees. So the measure of angle B, 35.027, and you're finished. There's a way that you can type that in all at once too. Maybe I'll show you that right now. Just like we did in the law of cosines video, we learned some shortcuts. So at the end, if you're hitting inverse sine, let's try to hit it at the beginning. And I want to type in 21 regular sine 119 close parenthesis divided by 32. Same answer. Cool. Number 2. Find lowercase b. Lowercase b, of course, is across from capital B, so it's right here. So if I'm looking for lowercase b, I'm going to use the version of the law of sines that has the lowercase letters in the top. And I want to determine which law or which fraction I don't need. So I definitely need the b fraction. And now the other thing is kind of weird. Oh, here's why. Because if we have two angles that are given, I immediately want you to find the third angle. So find this angle first. So it's 110 plus 110 plus 46 is 156. Subtract that from 180, it's triangle sum theorem. We get 24 degrees. Okay, so we're going to use capital C and lowercase c. The A doesn't matter. We're finished with that one. We don't need that one. So I'm just going to use the fractions that I need. Anything that I don't need, I'm going to erase. So the sine of 46. So that is equal to lowercase c, which is 13, over the sine of capital C, 24. Okay. So now we have, again, a situation where we're just going to bring this up into the numerator and multiply it by 13. So we can do that in our calculators in one really easy step. We don't have to hit inverse sine here because we're not trying to find angles. So this is 13 times the sine of 46. Make sure you close that parenthesis, divided by the regular sine of 24. 22.991. Lowercase b is 22.991. And that's it. You're finished. Okay. Number 3. 2 more here. Alright, sometimes you're not going to be given the diagrams. You have to draw your own. Alright, so we have to have a general idea of what a 52-degree angle looks like, what an 84-degree angle looks like, right? And you can use some references. You can use some basic references. I have references in my head that say, alright, that's about a 45. 90 is pretty simple. That's a right angle. Right, that's 90. So if I add those together, it's 135, so that's got to be something like this. And of course 180 is just a straight line. So those are some references that you can use to help yourself draw really good angles. We'll start with angle A. Angle A is 84, so that's going to be slightly less than 90. So if I draw this, I'm going to draw this one a little bit less than 90, maybe a little bit more. Let me erase that. A little bit acute right there. That's 84. All right, capital A is 84, little a is across from there, that's 53. All right, so I'm just going to close this off. 53 is across from capital A. All right, capital B we'll put up here is 52. Across from there is little b, that means this is C, little c. All right, and your job is to simply find lowercase b. All right. So if you know, maybe you didn't need the diagram, but for this one, I think it always helps, right? It helps me to see that lowercase b is what we're looking for. Its capital B is given lowercase a over sine of capital A. Cool. This is just like example 2. So you go to your calculator. We're going to hit 53 sine 52. Close that parenthesis, divided by the sine of 84. So 41.995. And that's it. All right, that makes sense, right? Because 84 degrees is bigger, much bigger than 52. So that means that the side that corresponds with A should be much bigger than the side that corresponds with B. That makes sense. Last one here. Most involved one is when the directions ask you to simply solve. Solve is kind of a vague word, but it means very specific things in mathematics. It means that you need to find everything that's missing. Okay, so we've got two sides and an angle that's not in between them. So this is definitely law of sines. We're using different letters here, but that's okay. Capital T, lowercase t, capital R, lowercase r, capital S, lowercase s. All right, so really when we do these problems where we have to solve, right, there's usually only one path to the final answer. And the reason there's only one path is because we don't have any other options but to solve for this angle first. We don't know angle S, so we need to find it. We can't do the R's until we get this other angle. So let's do that. If we're looking for angle S, let's do the sine of angle S over little s is equal to the sine of, I can't use the R's yet, so I have to use the T's, the sine of T over little t. So here we go. Little s is 30. The sine of capital T is 62. Lowercase t is 53. All right, we're going to hit this all at the same time in our calculators here. So we're going to go inverse sine of, let's see, 30 sine 62 close parentheses divided by 53. So 29.986. So the measure of angle S, 29.986 degrees. 29.986 degrees. And I'll highlight that one. Alright, so once we have two angles, we want to find angle R. So the measure of angle R, I don't really like to use answers to find a new answer, but we really don't have a choice. It's just going to be triangle sum theorem. So just in your calculators, just go 180 minus that answer, so second negative, minus the other side, or the other angle, which was 62. So 88.014. So that's the measure of angle R, 88.014. And now we're ready to find lowercase r. So I'll highlight that one too. That's a pretty big number. It's a big answer. Lowercase r is the last one. So if we're looking for lowercase letters, put those letters in the top. For the other fraction, I would probably use the two given pieces of info. So use 53 over the sine of 62. It's a better idea to use the given information than to use rounded information. All right, So now we're just going to take this sine of 88 and bring it up here. So in our calculators we hit 53. And the sine of that answer divided by sine of 62. 59.990. So R is equal to 59.990. We don't need a 0, so I'll leave it off. So those are our three answers. At the end of this thing, it's probably a good idea to put an answer box, which I'll put down here. All right, so draw a nice little answer box. Let me do that over. And let's see if there's a little trick on here that turns that into a rectangle. Cool. And maybe I'll make it a little bit bigger. All right, so in our answer box, we're going to put the measure of the three angles, the measure of angle R, measure of angle S, measure of angle T, little r, bring it over here, little r, little s, and little t. And we just want to consolidate our answers, make it really easy for your teacher to see that these answers are in fact your answers. I'll even call it the answer box. Answers. Let's see, measure of angle R is 88.014. And let's see what some of the other ones were. S, measure of angle S is 29.986. And the other three were given, I believe. Lowercase t is 53. Lowercase s is 30. And the measure of angle t is 62. Alright, so there are four examples on the law of sines, right? It's really important that you understand where and when you have to use each law. Alright, there's probably a good chance that you'll have the laws given to you on a formula sheet, but you need to know when to use them. And that's really the key.